Okay, we're just going to have a look at enhanced materials now as part of our work on forces and stresses, and we're going to focus on steel reinforced concrete. Now, concrete has been used for a long, long time as a building material, and the reason it's been used as a building material is because it is fantastic under compression. Concrete's a really, really strong material under compressive force. In fact, we use it now for the foundations of most buildings. We use it for the foundations because as the weight of the walls and the building presses down on the concrete, it gives a really solid base to build on. Okay, it can withstand massive compressive forces. The bad thing about concrete, however, is that it's very weak under tension, tensile force, which we know is a pulling force. If we used a concrete beam as a lintel or a beam to hold a roof up, it just wouldn't be able to support the weight. It would crack and break, therefore it would fail and collapse, as we can see in this little diagram here. We can, however, reinforce concrete by adding steel rods into the concrete mixture. So we have a steel lattice that is welded together or tied together that we can place inside the mold and set the concrete on top. And the full purpose of this steel rod structure is to increase the tensile strength of the concrete. In this way, it's an enhanced material. It's been enhanced by the addition of the steel rods to increase one of its properties. The property in this case is the tensile strength of the material. It makes reinforced concrete a really versatile composite material, used massively in the construction industry for walls, beams, roofs, etc. The one really key thing we need to think about here is that these steel rods or the steel lattice is pre-stressed before being cast into the concrete beam. If we just placed the steel rods into the concrete as it was setting, it would increase the tensile strength, but not as much as we would like. What happens is the steel rods are placed under stress, so they're basically stretched or pulled under massive tensile forces as the concrete is set around it. Once the concrete is set, then those tensile forces are removed. And what happens then is the steel rods try to relax back into their original shape, putting the concrete beam or the concrete slab under initial compression. That initial compression that the concrete is under before any force is applied to it increases the tensile stress, the tensile strength of the concrete beam, and it ensures that the concrete structure is far more resistant to tension and therefore resistant to cracking, fracturing, and wear and tear. So our enhanced material is steel reinforced concrete. A steel lattice is placed inside the mold for the concrete to be set around it. And it's very important that that steel lattice is pre-stressed, so it has tension applied to it prior to the concrete setting. So when the tension is released, that concrete is initially under compressive force, which reduces the cracking, fracturing, and increases the resistance to tension of that concrete beam.